I'm Anil Kumar sharing with you solution of question number 28 from the textbook Nelson on calculus and vectors. Now, we have already solved the first part of this in previous video. Now we'll see part B. F of x equals to 3x squared minus 6. The question was, for each function, sketch the graph of the function and find an expression for f dash x. Indicate any point at which f dash x does not exist. Let us begin by sketching a graph for this function. Okay, so let us say that's a coordinate axis. We'll first sketch 3x squared. We'll first sketch this part, 3x squared minus 6. As you know, I always make very rough sketch. So what I will do is, this is a parabola vertically stretched, moved 6 units down, right? So I'll just sketch a parabola with this red ink saying like this. So this is my parabola. Now this parabola is 3x squared minus 6. So let me write this as 3x squared minus 6. Okay, so whenever you want to sketch absolute functions, the idea is sketch the function inside, and absolute means make positive of it, right? So what we need to do is we need to flip the part which is negative, right? So this part from here to there is negative. So we'll just take a mirror image of this part and say, well, the function absolute x will be kind of like this. Do you see that? Now that becomes, okay, so this function now becomes the function for x. So let me write f of x here. So absolute value means all positive. Now as you can see, let me label this a bit more. So this is minus 6 for us. You can find these values by equating 3x squared minus 6 to 0, right? So let us say minus 6 equals to 0. So when you do that, you get x squared equals to 6 over 3 and x equals to plus minus square root of 2. So these 2 points are plus minus square root of 2, right? So you get minus square root 2 here and plus square root 2 there. So that is the function. Once you get this function, it's a good idea to write it as a piecewise function, correct? So let us now write this function as a piecewise function. I hope you have understood the concept. So sketch 3x squared minus 6 and then do mirror image or reflect the negative part to positive on x-axis as I've shown. So let's write down this function as a piecewise function. We can write f of x is equals to the inside function 3x squared minus 6. You see, it's the same function if we are considering from minus infinity to minus 2. So this is when we are considering from minus infinity to minus square root 2, correct? But it is negative of this when you are considering domain between minus 2 to plus 2. So negative of 3x squared minus 6 when you are considering it between minus 2 to plus 2. Let me include these points in this part, right? So minus square root 2 to plus square root 2. Okay. However, it is same as the function itself when it is greater than square root 2. So we'll write 3x squared minus 6 when it is from square root 2, sorry, I should not include this part, okay, to infinity, right? So that is how the function indeed is. Now the question is how to sketch and find derivative of this function, right? So one part you can check from the sketch itself. You know, derivative is not there on these points since these are corners. Do you see that? So at these points derivative does not exist, correct? And it exists at all other points. Okay, so that is one part we learned. But after all, what is the derivative? To find the derivative, let me write down the function with its derivative. So f dash x, so let's say, okay, let's do f dash x is equals to what? Derivative of this is 6x, right? So it is 6x when we are talking about the interval from minus infinity to minus square root 2, and be minus of 6x minus of 6x when we're talking about the interval between minus square root 2 to plus square root 2, and it's again 6x if we move from square root 2 to infinity, right? So that is the derivative. Now, to sketch a graph of this derivative, what can we do? These are all straight lines, so you just need 2 points. Okay, so one point which is very good to take is square root 2 itself. Okay, so square root 2 is around 1.4, right? And we know this point is around 6, right? So this is 6 for us. So approximately I'll sketch on the same graph. Okay, so for square root, let me select one light color. So first, let me sketch the center part, which includes my points, these 2 points, and the slope of the line is minus 6. It goes through origin. So that is the slope going through origin. If I write minus square root 2, then minus times minus becomes plus. So here we are expecting a positive value, whose value is 6 times square root 2. So more than 6, right? So I'm assuming more than 6, 1.4, around that much. So that is my point. Do you see that? I'm including it. Similarly, on the right extreme, I'll have this point which will be kind of here, right? So on this line, kind of here. Is that okay? So I'm joining these two. So that becomes f dash x. So this line represents f dash x for me, for the center portion. Okay. Now let's see the portion from minus infinity to minus square root 2. If I take a value which is minus square root 2, I will get a hole, since that point is not included, at 6 times minus square root. So minus of this value. So kind of here. Do you see that? So I'll get a hole here. Perfect. And if I take a point further negative, let us say 3, then it will be minus 18. So it's going further down, and of course it will go through kind of like origin. So I can draw a line which is like this, right? So kind of like this. Okay, so let me push this page a bit on the right. Similarly, if I draw this part, it will be starting from here, which is kind of higher than 6, right? So we can say kind of here, and going like this. Do you see that? If you extend, it will go through the origin, because if x is 0, well, this part is not within the graph, correct? Anyway, so I hope you understand how we have sketched f dash x. And it's very clear that it is minus 6x in between. So let me just show you once again. So that is one part of the graph between minus and plus square root 2. The other one is a straight line going away, as shown here, right? So that is how you need to sketch the function f dash x. Now, second part, indicate any point at which f dash x does not exist. So we can write down our answer that f dash x does not exist at, at x equals to plus minus square root of 2, right? Since you can see there is a jump discontinuity. Is that okay? There is a jump discontinuity. You can also see that these two values, when you approach from the negative side and from the positive side, they're different, correct? Here the slope is negative, right? So you can see the slope is 6x. So they are not the same, right? So that is the difference in the slope of the tangent on this particular graph. So it is negative when you are approaching from minus infinity to minus infinity to minus square root 2, and becomes positive thereafter till 0, and it changes, right? So we can say that the slope or the tangent or the function is not differentiable at plus minus square root 2. I hope that helps. Now follow the same strategy and try to answer the part 3 of this question. I hope that should not be so difficult. Thank you and all the best.